Okay guys, so this video is going to start us off with graphing quadratics. Okay, it's the first steps, okay, before we can get into graphing, really doing the graphing part. Okay, and you guys probably did this if you're taking Algebra 1, then this is the first time you've seen this. If you're in Algebra 2, then you've seen this before. Okay, or you should have. And in some of the videos, they might have been made for either Algebra 1 or Algebra 2. The topics are the same, you can use them. So sometimes with the assignments you don't want to pay attention to, but for this one here is being filmed in the late summer for you guys, late August of 2020. So graphing quadratics, the first steps. Okay, so first of all, what makes something a quadratic equation? And think about that for a second, and hopefully when you're doing this, you're either pausing the video, you're trying to answer my questions, because that's what's going to give you the knowledge you need, okay? And you need to be successful on the SAT or the MCAS test or future math classes. So I'm hopeful that you're doing this for the right reasons. You're not just speeding through the videos and writing down some notes. I'm going to be looking for these notes, so you want to make sure that you take notes on this, okay? Because part of your homework assignment will be me going through and checking notes and seeing that you have all the things that I have on these videos. So what makes something quadratic? This, first of all, is linear, okay? This one here is linear. If you graph it, it's going to be a line. That's what I mean, line, linear, okay? If you had this one, y equals the absolute value of x, that's an absolute value graph, okay? And an absolute value graph is V-shaped, okay? So when we talk about quadratics, what makes it a quadratic is the exponent to the second power. So if we had y equals x squared, that's the most basic kind of a quadratic, okay? These graphing quadratics, quadratic equations, okay, and we're going to talk about all the properties of these quadratics. The quadratics they're called, when you graph them, they're called parabolas, okay? It's called a parabola. And the general form for a quadratic equation looks like this: y equals ax squared plus bx plus c. The highest exponent is a 2. You don't have any letters, x's, being multiplied together, okay, because then it wouldn't be a quadratic. And when we look at a quadratic, we'll talk about this one and we'll come back and talk more about that. The a is really important, okay? The a determines whether it opens up or down. If your a is positive, which means your a is greater than 0, then the parabola opens up. And if a is less than 0, then, which means it's negative, then your parabola opens down. Okay, so these are U-shaped. Parabola is U-shaped. That's one that opens up, and this is one that opens down. Okay, so again, they can open up or down, and it's based on your a. If your a is positive, or if your a is greater than 0, it opens up. If your a is less than 0, then it opens down. Now, with these quadratics, it's important what points you pick. If you had a line, okay, let's say I had y equals x plus 7, and I want to graph the line y equals x plus 7. When I go to graph that, if I wanted to do it with an XY chart, I could pick any points that I wanted to. I could pick 1, 2, and 3. I could pick -7, -8, -9. If I really wanted to, it would be a pain, but if I really wanted to, I could pick 141, 168, and 204. And I could plug those in here and get y values and graph that. Now, I would never recommend these, because to try to graph something like that would be a real pain, but you could. It doesn't matter which points you pick. Now, when you have a parabola, it matters what points you pick, because if you picked a bunch of points, let's say you pick 6 points, and when you graph them, they look like this, you might think that that's linear. Okay, so it is important what points you pick, and there's one point that's more important than the rest, and that point is called the vertex. The vertex of a graph that opens up is your smallest point, And the vertex for your graph that opens down is your biggest point. So this would be a minimum, this would be a maximum. Now you have to find that vertex first, and if it's in standard form, which we have up here, okay, which is y equals ax squared plus bx plus c, then your vertex, the way that you find that with the coefficients here, okay? They have to be in this order. That's the correct order. That's what's called standard form, okay? This is called standard form, and the vertex, the x coordinate, okay? The x coordinate of the vertex is found by doing negative b over 2 times a. So you take the opposite of this and put it over this, and that's the x coordinate of your vertex, okay? To find the y coordinate, you plug the x in. Plug in x, okay? So I'm going to go to the next page here, and we're going to still have at the top the y equals ax squared plus bx plus c. And we talked about some of this stuff already. We've talked about this being a parabola, being U-shaped, meaning it's going to open up. And we know if our a is greater than 0, it opens up. And we know if our a is less than 0, it opens down. Okay, and we know our vertex is negative b over 2 times a. Now, what's really neat about these parabolas is they're symmetrical. Okay, and that's a term that you might have learned from geometry, and to be symmetrical means like the capital letter A is symmetrical, because if I did a dotted line down there, the left side and the right side are mirror images of each other. Okay, so that means that they are symmetric. So the parabola is symmetrical. There's a dotted line, imaginary dotted line, that goes through your vertex, which makes the left part of your parabola a mirror image of the right. And it's called, has a special name, axis of symmetry. Okay, now the axis of symmetry is a vertical line, and we know that vertical lines are x equals. If you have a hard time with that, remember these two words: Xavier and Yahoo. And if you have x equals, it's a vertical line. X equals a number, say x equals 2, it's a vertical line. If you have just y equals a number, y equals -1, then that's a horizontal line. So the axis of symmetry is x equals whatever that x coordinate of your vertex is. So we're going to say x equals negative b over 2 times a. So all of these things are really important when we talk about quadratics. Okay, two more things that I'm going to throw in here we'll probably talk about in a different section, and that's a max and a min. Your maximum point and your minimum point are always your vertex. So if something opens down, then we have a max, and that max point is your vertex. If it opens up, this point is here, that point is a minimum, and it's the y of your vertex. Okay, the max and the min are the y of your vertex. Okay, so what we're going to do in this section, or in this video, is we are going to find the vertex and axis of symmetry. And I'm going to show you how to do that for 3 different forms. Okay, I'm going to pause this video for 1 second. Okay, I'm downloading the process, also downloading videos. So I'm going to pause this for 1 second. We're going to come back and we're going to do find the vertex and axis of symmetry.